So consider that deep learning is full of brain activity. So you are going to please mute yourself.
वो ललित ये तो वो ललित सर आते थे ना पढ़ाने, लेकिन एग्जामिनर बाहर का तो
Jyoti Singh, please mute.
हाँ सीरियस का हो सकता है, अब वो उस पर बीपीआई से मुझे नहीं कंफर्म है। इसका एग्जामिनर से आपको ढूंढ के लाना होता है।
Okay. Okay. So for this, deep learning is full of brain. So here I'm telling you, the weight will be randomly initialized. You can compare it with one scenario. You are going to learn one new concept. Okay. One new concept like natural language processing. So when you hear that word, when you start going to learn, as a whole, you have some random idea about it, right? You have some random idea about it in our brain. So when we study repeatedly, when we learn the exact concept, then only you will understand clearly what is what. So at the first start, usually you have random thought, right? Do you all agree with this? Do you all agree with this? So like same, right? Like same, this is a brain activity. So this weight will be randomly initialized. Due to training process, due to back propagation, the correct weight will be, the correct ratio weight will be altered. This is the first point, and this is the first one that you have to keep it in our mind, like the difference between the machine learning and deep learning. If you want to say it in a technical term, you can add this point. So this is a hidden layer. This is the hidden layer, and this is the input. What is hidden layer? So I told this input is now visual, like you're seeing your tree picture. That is your input. Automatically, your brain wants to classify that whether this is a tree or not. So what is happening in your brain is hidden. Finally, you will say the output is visual. Again, it may be audio, it may be a label or anything, but the process inside your brain is hidden. So Suresh Kumar sir have asked, it's automatic or not? It's automatically initialized. So in coding, we will give, please use the random weight, right? So hidden layer is nothing but how our input is going to check with each neuron in our brain and how it retrieves the exact output for that. So now our input, consider this, all the input is going to check with the hidden brain of one neuron. Okay, we'll see how this one neuron is going to be validated or not. So for this first neuron, we are randomly initialize the weight as 0.5, and for second neuron 0.1, then minus 0.4, 0.3, minus 0.2, and minus 0.3. This will be automatically initialized with the help of coding. So in coding, we have to give randomly initialized. So random number generator. So what our next process is, we are going to multiply these two input as well as weight, like linear algebra 1. And there is a one bias term. Bias will be 1 B naught, that is 1. So after this process, okay, after this process, we have respective value. 0.53 into 0.3 is 0.15. So what is the next step? Now we have one mathematical calculation. We are going to sum all this value. We are going to sum all this value. This is called net function. So when we discussed about the single perceptron, We see in the diagram like input layer, weights, hidden layer, net function, and activation function. So we discussed what is input layer, what is weight, and hidden layer. So now we are going to explore what is net function. So net function is nothing but we are going to add this all value, that is 0.08. Then what? Sorry. So what is activation function? So now we are going to see detailedly how it works in one single neuron, right? So the summation is nothing but your net function. Let me change the color. Net function, summation of all the value. Here I am getting 0.08. So the next process, the output of this net function is given to the activation function. How many of you have heard about activation function? Please type it in the comment box. How many of you know about activation function? Please type it in comment box. Okay. Okay, I hope many of you have learned about activation function. Do you have exact explanation of how activation function works? Sridevi ma'am, please.
Hello. Yes, madam.
Okay. So threshold. Okay. So this exact activation function is going to help you to validate that whether that particular neuron is having information for your question. So this activation function is going to decide whether you have to keep this information or not. So if you want to compare it with your actual brain works, so in between that hidden layer in our brain, it checks for all the neuron. It checks first neuron. No, there is no information regards to this question. Then it will jump to next one, next neuron. It checks. Yeah, this neuron has information for this question. Then hold that neuron. So like that only for this particular cell, this particular hidden neuron has information for this problem statement. How you are going to decide that? So we have many activation function. So based on this activation function, we are going to validate. So one of the famous activation function is ReLU, which means nothing but the maximum comma 0 comma x. So 0 is constant, it's going to be there. Then x is nothing but the net function. Based on this two value, you have to check, you have to take the maximum value. Which one is the maximum value? So 0.08 is the maximum. So it got selected 0.08. So this has useful information. For example, now consider this activation function gave minus 2.15. 2.15. Right? Now your ReLU function is going to be max 0, minus 2.15. Right? Minus 0, 25. Now tell me which one is the maximum value based on these two value? 0. Right? Very good, 0. So when it comes 0, it automatically tells that in this particular neuron, for this kind of weight, there is no information you are looking for. So please don't look for this neuron. So this is one single perceptron. So what is single perceptron? So these are the activation functions. You can check it later. Identity, binary step, again sigmoid, logistic, tan, ReLU, parametric, and many more. And activation function is also one of the playable parameter you can check for your research work. So this setup, this whole process is for a single perceptron. How your input is checking with one neuron and validating that one neuron. After that, you can convert the single neuron into multiple neuron. Single neuron into multiple perceptron. How? Like same. Again, for this setup, random weight will be randomly initialized. For this weight, we are going to validate whether this particular neuron is having information or not with the activation function. Like this, you can check with many hidden layer neurons, right? You can add many hidden layer too. Here I have showing for one hidden layer. Some of your problem statement may need 5 hidden layers. Some of the problem statement give good result at even at one hidden layer. So again, this is a playable parameter. You can check until you get good accuracy for your model, right? So after that, we are having one output layer. So again, from hidden layer to output layer, weight will be randomly initialized. Again, same process. What process we have discussed here, it applies for all the process. So when it comes here, okay, when it comes here, it will check for, I hope you all know about the cost function. What is the cost function? Actual value minus predicted value. Actually, that is true. If you are receiving some other value, then there will be error. Like for example, say 30. So this is the first feed forward process. So next process is how this is going to alter the weight. How it's going to learn perfectly. So we have 30 as a error difference. Then based on backpropagation, it will alter the weight. Again, it goes for feed forward. Again, check for the cost function. Based on that error, again weight will be altered. Again, for this weight, feed forward will happen. Again, it checks for cost function. Again, it goes for backpropagation until you get minimum error of 0.01. So it goes on the process. So for backpropagation, okay, for backpropagation, we are going to use chain rule. So the difference in the desired value based on chain rule, value will be get altered and it will be reflected to this and it will be reflected to this. Now all the weights will be changed based on this difference value. Now it makes sense, right? How you can compare this with your brain? Like we are keeping test for the 10th student, right? The first test, that student is scoring around 70 mark and the teacher is asking the student, please correct your mistake. So for same question paper, test number 2, and he is securing 80 mark. Again, teacher is telling, please go and correct your mistake. So after correcting the mistake and after learning what are the mistake he left in this process, he is going for test number 3 and he is securing 95%. So the thing is, first he is studying, that is a feed forward, and getting output is a feed forward. When he is checking for his mistake, that is a backpropagation. Again, second feed forward, third feed forward, until you get the desired accuracy, it keeps on in a loop, right? So there are most important term how we are going to learn this process. So two important thing, one is the learning rate and gradient descent. Any idea about it? Gradient descent. If you know deep learning, definitely you would have crossed this word, gradient descent. right? How this gradient descent works? Any idea? How this gradient descent work? So fully we are looking for the minimum error, right? Like global cost minimum error function. So in our model, there is a possibility of increasing the model, increasing the error value. It comes to decreasing value. If we haven't checked again, it may chances of increasing. So to explain this particular property, the perfect example is a parabola. Do you all agree? The perfect example is parabola, because parabola have a center point, minimum point, and it have both increasing point in both sides. So if it travels from this side, from decreasing point, when it reaches in the global decreasing point, again there's a chances of increasing. So again you can compare it with the test. So when properly maintained by the teacher, he secures 95 and up to third test. So teachers thought he is getting good mark like 95. Hereafter we don't want to say any correction to him. He will keep on working on this. But when there is no monitoring for the student, again there is a chances of going to backside 75 percentage. So whenever it comes to learning, there will be the highest peak as well as the lowest peak. So our area of interest is we have to reach this global minimum error. Global minimum error. Right? So when randomly initialized, when you know one concept randomly, at that time your assumption may be wrong about that particular concept. So when your learning rate increases slowly, when you start studying this, each arrow considered the learning rate. When you are day by day improving to learn that concept, finally your increasing rate was superb. Like finally you got the point how natural language processing works, how deep learning works. Then you have to stop immediately. Again, if you refer more thing and confuse yourself, again there is a chances of misconception of the concept. Like same, you can consider this a gradient descent. Then what is learning rate? What is learning rate? So learning rate wants to be very slow. So in back propagation, we are altering it. Differences, for example, 30% error, we are getting 30% error. Immediately with the help of differentiation, easily we can change our weight at one time itself, like one loop itself. Immediately you can get the correct answer. For example, that student is checking for the test, correcting the test. Okay, I have left mistake here, immediately he start writing test and correcting those words only. He will get good mark at the time only. But again, if teachers start asking after 1 week, again he will repeat the same mistake, because immediately he has corrected without any proper understanding into the brain. So how we are going to mention this learning rate is in propagation area. Okay, in back propagation area, difference is 30. So it's going to update all the value. We want to get 100%. So we are going to multiply with the learning rate of 0.01. So immediately the value will be collapsed. It comes to the lowest increasing point, so that there will be the minute learning in your performance. Again, it will be get changed to some value. Again, we are going to multiply by 0.01. Again, learning rate is a playable parameter. You can play and check with your analysis for your project. So when your learning rate is slow, it comes like slowly and reaches your target. When your learning point is high, immediately it's come here. Again, it missed the target. Again, it start increasing. So we have to approach this target. This is our global minimum in gradient descent. Right? So always keep it in our mind. Learning rate should be slow so that you can achieve your target, which is minimum error. Right? So learning rate is nothing but on differentiation, the chain rule, you are going to multiply with one small amount of value. Right? So observe this graph for 30 seconds and tell me the difference. Actually, what's happening in this graph? Observe all the parameters. So it's showing you the exact learning step. So first we'll come to the question like, so wait. Now step 1 is 10, then 4. When step increases, learning rate increases. Slowly it's decreasing. Right? So this is your first learning rate. Immediately you are converting into 4. Then immediately you're converting into 2. From this, you're coming step by step. When you're coming reaching your global minimum, exactly your model, regression model is exactly fitting towards your data set. You all can see this. So if it jumps directly here, then it will not fit here. Directly this will go here. This regression line will move here. We have to fix exactly here so that the learning rate should be very slow. Clear? So the next term is epoch. What is epoch? So one epoch is when the entire data set is passed forward and backward through the neural network only once. So when consider that your entire data set have 2000 images, when all the 2000 images went for forward and backward through neural network, then we'll say that is a one epoch. Then what is batch size? The total number of training example present in a single batch. So for example, we have 2000 image, we can split it into a 4 batch, like 500, 500, 500. Then what is iteration? To complete one epoch, batch size is 500. So we need 4 iterations to complete one epoch, right? So this is how you can split the whole data set into epoch, batch sets, and iteration. So these are the parameters that you have to give in your programming, right? So this is a complete pure vanilla like artificial neural network, right? So, so far any doubt in this artificial neural network? Any doubt? Any doubt? Okay. Shall we move to next concept? Do you want me to take a recommendation system or convolutional neural network? So I thought of taking both recommendation system and CNN, but I hope there will be no time. We have 15 minutes. Recommendation system or CNN? So CNN, convolutional or recommended system, CNN. Okay. So majority is like CNN. If time permits, I will quickly go through how recommendation system works. Okay, I will try to. Okay, yesterday resource person covered CNN. Okay, great. So let me take 5 minutes and quickly review what is CNN. Then I will go back to recommendation system. Okay, great. Thank you for your response. So I hope you all know about the structure, right? We have convolutional layer, max pooling, second convolutional layer, average pooling. So for first convolutional layer, we have several parameters like 4 kernel size, padding, activation function, right? So why they have named convolutional neural network? So convolutional is a process, one process. Output of convolutional is given to the neural network, right? So first you have to understand what is filter, and this is how from the background it got eliminated with this respective filters, and this is how you can see the filter, right? So exactly the pattern alone got reflected in the filters irrespective of the background. Here you can see, right? So first is you have to know what is filter. Then padding size. You have to pad the output image. If it is full padding, if it is full padding, you can increase your output image. If it is same padding, you can retain your input image like 5 cross 5 into 5 cross 5, right? If it is valid, then you can reduce your output image size from 5 cross 5 to 3 cross 3. So here you can see how it goes. So again, it works for the 3 channel, red channel, green channel, blue channel, right? So next one is straight. So what is straight? So straights are how for each channel, how your filter is going to multiply and give you one respective output like this. So if a straights is equal to 2, it's going to leave you this 2, then it directly jumps to 1. If it is straights 1, it leaves only one cell. So here you can see how straights do work. So again, based on the straights, you can do some process. So this is how we are going to get output image. This is the calculation for straights and kernel. Okay. So now we got some idea about straights, then kernel size, then activation function. So consider this is a single input image. This is a full work how convolutional layer works, converting that into a 3 channel. So first channel with input 1, filter 1, and gives you the respective output. Then for same input, filter 2, then respective output, it will be stacked here. Then filter 3, filter 4. For the same input, we are dealing with the 4 filter. If it is 35 filter, then 35 channel will be created. 5 cross 5 into 35. This is the most important part that you have to know. So up to this is the convolutional. Then again, we are going to activate with the activation function. We have to validate each cell with the activation layer. So what concept we have discussed, that is activation layer. So up to this is a convolutional process. Output of this, we are going to check with the activation layer. Again, 5 cross 5 is converted into 5 cross 5 with the validated output. So this is first convolutional layer. The next one is max pooling layer, kernel size. So 5 cross 5 into 4. Okay, max pooling is nothing but if it is max pooling is 2 cross 2, then you have to take 4 into 4, sorry, 2 into 2. Based on this, which one is maximum, you are putting into a one new cell like this. Right? So finally, you are stacking. If it is filter is 35, then it follows, goes on 35. So when you're stacking your color image with 35 filters, 240 filters, at the time you're going to get only the features. So at the output of this convolutional layer is, you can see this hand picture is after the layer of 40 layer, like hidden layer for convolutional layer 40 layer, and filter is 256 filter. When we give 256 filter, you will get output, final output like this, only the features. This is the future of this image processing for this particular image. Automatically the future alone will be get saved. So here if it is 256 filter, then 256 images are overlapped together, so that only you can get such type of 3D image. So here this is 40 and 286 filter, and this is 40 filter. This is for 40 filter, for filter 95, and this is 303. So this is good, right? So when you increase 303, this is little bit exploded, right? So this is about convolutional neural network. So this image, so output of this convolutional neural network will be given as an input to neural network. So here I will explain this block diagram. So finally here you can see up to this is your final output. Then you are giving that into a normal artificial neural network, what we have discussed. So normal artificial neural network is called dense layer or fully connected layer. And I will quickly show you one. Actually, yes. So this is a digit classification, right? So if I write 3, this is your first layer, this is your input layer. You can change it in what manner you want. First convolutional layer, max pooling layer, convolutional layer, max pooling layer. Finally, these two lines are dense layer, which means neural network. All this neuron will be connected with all the neurons and checking, and finally giving the answer is what. Right? This is the visualization of how convolutional neural network works. Right? Okay, so I have explained in very short. So we'll see how recommendation system engine works. So types of recommendation engines are collaborative recommendation engine, under that user-based, then memory-based. User-based or memory-based and item-based. Under collaborative, we have two types. Then one is content-based recommendation system, then popularity-based recommendation system. Right? So first you will see what is user-based. So if it is user-based, consider that you are in Amazon, or you consider you are in a Netflix. Right? So when you automatically log in into that particular login of your login, automatically it starts searching for similar user. Right? So this is the you, and you liked, for example, you like the carrot and you like the pizza. And similarly checking for similar user. This similar user have tasted the carrot pizza, but he haven't tasted the burger. So that these both people are similar, so that I can recommend this burger to this person. So this is a literal overview about how user-based works. So nearly Netflix is giving the report 70% of watch time is fully based on the recommendation system. So recommendation system is a recent trend, as one of you have told. So now we'll dive deeper into how it exactly works, how they are correctly recommending the product to us. So consider this is a data set and this is a movie data set. We are going to use movie data set to recommend the films. So this is the concept you can applicable for any kind of recommendation system that you want to build. Right? So we have 1 lakh rows and 4 columns, respective user ID and respective movie with respective rating. So we are going to create pivot table like this based on this data, which means how many unique user ID. So unique user ID is 942 and unique movie ID is 1 to 1682 unique movies. And these are based on the ratings. We have plotted based on the ratings. So now the next step is we have to create the similarity table. What is the purpose of similarity table? How you can ready the similarity table? How you can build similarity table? So we have two options. One is using cosine similarity and another one is using the correlation similarity, correlation process. So here I have used the cosine similarity. First, this is user based. So I'm going to take for user. So this is user 1, user 0, 1, 2, 3, and this is also user. So user 1, how much it's similar to user 1? How much user 1 is similar with user 2? How much user 0 is similar with user 3? So this is the first step that we have to build. Right? Then prediction table. What is prediction table? This is the core point of recommendation system. So here you can see in this pivot table, we have take the third user. So third user haven't watched the movie one, so that that is 0 rating. So the third person haven't watched most of the films. And first user haven't watched, actually up to this there is no, if we can take the user 2. So the second user haven't watched movie second, third, 4, 5, but he watched movie 1. So the thing is, we are going to do the prediction. We are going to fill these values based on machine learning algorithm. So in the perspective of how, if this person have watched this movie, how much ratings you'd have give for this particular film. So in this perspective, we are going to predict the table. So to understand that how you can predict that particular value, we'll take some small example. It is Joe, John, Al, and Nathan has watched Star Wars, Hoop Dreams, Contact, and Titanic. Right? So here Nathan haven't filled for Titanic. So we are going to predict what if the Nathan have watched Titanic, how much rating he would may have give the rating for this particular film. Right? So we'll check now. So we have to do the correlation similarity check for Nathan with all the users. Right? Cosine similarity of Nathan with Joe, cosine similarity of Nathan with John, cosine similarity of Nathan with Al. So here you can see 0.99 and 0.64, 0.91. Right? So this is a respective similarity score Nathan with the similarity users. So after this calculation, we are going to take only they have taken these value. because they want to predict for Titanic, right? So they haven't included. Now you can see this is acting as a vector in a 3-row vector. So now we are going to do simply we are going to do multiplication of 4 into 0.99, 3 into 0.64 and 2 into 0.091. And this is the calculation for that. So finally, we are getting answer is like 3.30. So based on the similar users, we have predicted what if Nathan have watched the Titanic, how much review he can give. So he may give 3 based on that. This is fully based on the user similarity, right? Like that, where and all we have this empty cell, using the same calculation, we can predict and we can replace it with the respective cell, right? Likewise, like that, I have filled with all the columns. So now you can see the prediction table is fully filled. Now user third is fully filled with 91682 movies. Right? Up to this, consider up to this procedure, this is going to be constant. Now consider that you have logged into Amazon Prime and your user ID is 34. Algorithm start works like automatically it start finding the similar user, right? The next step is it start finding the similar user, this similar user watched movie list. So this user have watched these movies and this user have watched these movies, and these are movie IDs, as well as we are taking the target customer ID also, movie ID also. So we are going to create all this movie ID into one single list. And we have to segregate that what are all the movies watched, common movies. So similar user also watched 34 and the target user also watched 34. So we have to segregate only the movie which was not watched by target user, right? So from similar user, this target user haven't watched movie 50, movie 78, 87, 90, 673, 876 and 893. Right? We are going to recommend these films to the target user. So what if we so we want to recommend only top movies. Here I have representing only the small count, but this is the working principle even if you have 1,000 recommendation movies. So we are going to take from the prediction value. For this user 34, go to user 34 row and select for movie ID what is the prediction value. What if this particular user, okay, have watched the movie 50, he would give the rating is like 0.99. So this is purely machine learning predicted value. So there is a chances of liking, highest chances of liking movie 50 by this target user. So the system will recommend movie 50 to this target user. So with the help of threshold, like we can give threshold like 0.7. So if it is 0.7, it will start recommending only movie 50, 78, 87 and 90. Right? So again, we are putting into movie title and we are taking only the movie names. And steps for user-based recommendation system. What are the steps I have explained to you? I have summed up like step 5, step 6, step 7, step 9. right? So this is the code. Finally, I have created into a list 5. This is user 5, then we are passing similarity table, then we are passing user prediction, then how many similar user you want to select and what is the threshold. Finally, these are the movies will be recommended to user 5. So any doubt? So if you have any doubt, you can ask me. So any idea about how numbers of layer to choose a number of neurons should be resolved through trial and error? Yes, sir, it should be resolved through trial and error because for each data set works different. So again, if you can compare it with your real time. So some of the concept will be very easy for you. At one shot, you will learn. Some of the concept you have to repeatedly go for several times. So what is difference between item based and content based? So for item based, instead of selecting the user, we are going to select the item. So based on this, we are going to select a similar item and what are all the items is liked by this user. So based on item, we are going to recommend to the user. So quickly, I will scroll the slide. So this is a data set, same data set, same pivot table, but here I have created the similarity table for item. For user based, we have created the similarity table for user. Here we have created a similarity table for item. Again, the same prediction table follow, right? This is for movie based. So now we are selecting item 34. Okay. And these are the similar items. So for example, user ID 34, 36, these items are eaten by user ID 34, 36, 67 and user ID 67, 63. Again, same concept. Instead of user, we are going to deal with item. Then this is a unique user ID which was not eaten by that particular person. Then this is a predicted value. Then we recommend this item to this user ID. So pizza is not eaten by user ID 50, 78, 87 and there is a user may like the chances of liking pizza is 0.99. So this is the exact difference between the user based and item based. Again same, right? The next one is content based. So content based is we need three. One is user vector and movie vector and content vector. Content vector is the user vector into movie vector. Here we are going to take movie vector. For example, we have 18 journals. For each movie, we can categorize into 18 journals. Based on journal value, we are going to calculate which can be recommended to person. So for one user, for user 1, have watched the movie 0 and the journal movies 1 comes under journal 8. So based on this calculation, we are going to create a vector for single user for all the users. And this is the vector, user vector, and this is for user vector. And this is content vector. Content vector is nothing but the dot product of user vector and movie vector. So finally, if I give ratings and content vector for the person 45 and I give 0.3, then these are the movies will be recommended to the person. And most importantly, the working principle is fully based on the content. That is content based recommendation system. So, what is popularity based recommendation system? So, I told all this recommendation will be based on past data. What if the new user comes? What if new user come, that user don't have any past information, so that we can recommend the popular things like popular movies, popular item. That is called the popularity based recommendation. So any doubt? So actually I will share several link which you can follow us in LinkedIn as well as in Instagram, because we offer so many online courses and webinars, free webinars, so that you will get idea about it. So this is first link is my LinkedIn profile. You can follow it. Second one is for this particular AI course, I am the instructor. So I'm taking this course live interactive session. And second link is AICL training LinkedIn page and AICL Instagram page. Right? So what are the ways to calculate the similarity values? So similarity values is one is cosine and another one is correlation. You can use cosine as well as the correlation. So online resources for self-learning in specific project repository to proceed further. Actually, each instructor will follow the different pattern of learning. So my wish is, I can say for self-learning, you can take one particular topic and you can refer all the blogs based on that particular topic. So there is no, this book is good and you can learn everything what you want to know. So up to me, there is nothing like that. If you want to understand what is natural language processing, Google it, and there are several blogs, and you can learn with several perspective, so that finally you can come to one conclusion. Right? So far, any doubt? So to follow up the recent technology, you can follow Google Brain, right? Then you can follow many Instagram pages regarding artificial intelligence. Then, and in LinkedIn also, you can follow the AI members. So, any doubt so far? Yeah, my contact number is 888-39-16171, and my mail ID is Ramisha at Ramisha at astron.ltd. So if you have any doubt regarding this field, you can ask me. I know data science, then descriptive inferential under data science, then machine learning, supervised, unsupervised, semi-supervised, then in deep learning, ANN, CNN, RNN, LMTS, okay, then natural language processing, as well as the computer vision. Right? So you can give some feedback in this comment box about the content delivery. Is this sufficient? Is there anything that I have to improve?